All right, number 6, again, U substitution. I'm going to choose 1 plus 8x squared as my U expression. And so U equals 1 plus 8x squared. And du, the derivative of that would equal, well, derivative of 1 is just 0. Derivative of 8x squared would be 16x. And I want to rewrite my limits. So U of 1 becomes 1 plus 8 times 1 squared, or 1 plus 8 can equal 9. And U of 0 is going to equal 1, oops, it's going to equal 1 plus 8 times 0, or just equal 1. Okay, and I'm almost done, but just one little wrinkle here. Du is 16x. I have an x, but I don't have the 16, so I need to get a 16 here, right? And we're going to use the technique we've been using before. I'm going to go ahead and put a 16 in here and offset that by 1 over 16 out here. That's effectively, I multiplied it by 1 over 16 times 16, which is just multiplied by 1, which doesn't change the value. But that allows me to have a perfect U du expression in here. U to the 1/2 times du, although I have to multiply by 1/16 in order to have that luxury of having that nice, simple expression. And then I rewrite the entire integral in terms of u. So this equals 1 over 16. Limits change. Instead of 0 to 1, it's going to be 1 to 9. And it's going to be u to the 1/2 du. Okay. Now, what's the antiderivative of u to the 1/2? Well, it's going to equal 1 over 16 u to the 3/2. In other words, I raise 1/2 by 1 or 2/2. That's up to 3/2. Divide by 3/2 or multiply by 2 over 3. And I evaluate that from 1 to 9. Okay. And I want to clean up some of this arithmetic now, right? So I'd like to sort of combine these fractions, 1/16 times 2/3. 2 and the 16 cancel out, so it's 1 over 8. So it's going to be 1 over 24. 3 times 8 is 24. This becomes 1 over 24 times u to the 3/2 evaluated from 1 to 9. Okay. So this equals 1 over 24, 9 to the 3/2 minus 1 to the 3/2. Okay. Equals 1 over 24. Well, 9 to the 3/2, well, 9 to the 1/2 is basically 3. 3 squared is 27. 1 to the 3/2 is just 1. So this equals 1 over 24 times 26. And if I divide both those by 2, I end up with 13 over 12. That's it. Oops, 13 over 12. All right,